Assalamualaikum and very good evening to my teachers and fellow friends. Okay, my name is Muhammad Khairul Ikhwan bin ALWI from class CEEE 2423C. So today I want to present to you microprocessor lab 1 ECE for ECE 521. Okay, first for the exercise lab 1, for the question 1, write a program that will store 0x30 into R0, copy the content of R0 into R5 and then save data 0x45785612 into memory location 0x40000030. Execute the program and explain the difference in the result. Also discuss the addressing mode of each instruction used. Okay. For question 1, I have do the coding, so we will see it here for question 1. Okay. As usual, we make the area my program code read only export main entry until main. This is the format for the coding and again but again and so this is the format for the coding. So first, we move 0x30 into R0. This is called as immediate addressing. Second, we must move the R0 into R5. Move R0 into R5, which means it is register addressing from register 0 to register 5. Next, we declare the register for R1 is 0x45785612. Next, for R2, we declare is as 0x40000030. And then after we declare the pointer, next we must store the R1 into the memory of R2. Which means it is named as indirect addressing, or in the colon it is called immediate offset. Okay, again is for looping at here and we end the coding. So let's take a look. First we set as nucleo, CM6, we take the core device, we take the startup. Okay, next we take a look at the debug, use simulator and search file debug.ini and press OK. So we build the coding, so we can see there is no error and one warning. It doesn't matter there is many of warning, as long we get zero error is okay. So next we run the coding to see the result. Okay, let's take a look at the coding one by one. First, we click on the run to cursor line and then we move step by step to see the coding. So press click at here, step. So first R0 it is declared as 0x30 at here. R0 0000000030. Okay, next we must move R0 to R5. So we click the step, so we can see R5 from all the zero value is changed to 00000030. It is same as register 0. Next, we declare the pointer at LDR R1 and LDR R2. So we click at the step. So R1 it is become 0x45785612. So next we declare at pointer R2 0x4000030. Okay, after we declare the R1 and R2, next we must store R1 into the R2. It means indirect addressing. So we click at the step. So you can see when R1 is enter at the R2, R2 is the memory ni at, in the bracket, close bracket, and R1 is enter to the R2. So when R1 is enter to the R2, it will copy the number from right to right, from to right until left. So before this, the number at here is 0. After we store R1 into memory R2, it will copy from the right to the left. So it will take two number, and the two number and copy it into the memory. So we can see at first, one to number, it will copy at the first 0x40000030. Next, we will copy 56 into here, 56. Next, 78 at here, and next 45 at here. So it will copy the two number, and two number into the memory. So next, after we store, there is a looping again, be again. So the coding will end at here. So let's take a look. After step, there is no run of the coding. So the coding is finished. Okay, next for the question 2, write and execute a program that will add 0x20FA5690 with 0xFE123089 and 0x34589710 and save the sum into register R7. Record the change in CPSR as well. So let's take a look at the coding. So when we say save the coding into R7, so first we declare the counter. So let's take a look at the result. Run the debugging session first. Okay, let's say at the lab 2, LDR R0 we declare as 20FE5690. Run the cursor line and by step. So we look at the register for the R0 and then R1 and then R2. So we have declared the R0, R1 and R2. Next, we do the addition. So the question said that want to look at the change of CPSR. When want to look at the change of CPSR, so addition will be add with S. So that will be change and CPSR. So next we add R1 with R0, so we get R2. When we so we look at the change of the CPSR and Z, SID, and V. When we R1 plus with R0, so N, when 2 plus, so for N, we take a look at the result of R3. There is only 1. 1 is mean it is below than 7, so N is equal to 0. If the number at the left is higher than 7, so n is equal to 1. Next, for z, we will see when all of the number is 0 and z will be 1. But there is a number, so z will be 0. So for carry, when R1 is plus with R0, so 2 plus with F, we will get 11. So that is carry at the left, 11. 2 plus F will be 1. And then another one will be add to the left, so will be 11. So there is a carry. That's why C is 1. And 0 will we see when 2 plus F in the binary number. When 2 plus F in the binary number, F1111 plus we 10, we will get 10001. But we will see only 4 binary number, and then at the left we will get 0. So 10, the overflow will be 0. Next, we will add LDR to LDR R2 to with R3. So the result will be get R4. And then we take a look at the CPSR. So step again. When R3 plus with R4, R3 plus with the R2, we will get this R4. So let's take a look at the end. And at the left, we get 5. Is lower than 7. So it will n will be 0. So Z, that is all of the number, so it will be 0. So how about carry? Carry 3 plus 1 will be 4. So there is no carry occur. So the carry is 0. And how about the overflow? Overflow when binary of 3 plus 1, we will get binary 3 plus binary 3 plus 1, we will get 0 1 0 0. At the left we get 0, so the overflow will be 0. So next, the question as us say that we must save the sum into R7. So I use move R7 R4. So R4 will be copied to the R7 at here, and then next again be again we looping at here, and then end of the coding. For question 3, write a program that will store 0x2936FEDA in R8 and then perform the following instruction on the content of the register 4 times and comment on your result. So let's take a look at the coding I have done before. So as usual, do the format and again be again, and then at here we do the coding. First, declare LDR R8 as 0x20FA5690 because the question want the 0x2936FEDA into R8. So we just declare it into the R8 here. Okay, next we do the program that the question want. First, ASR, the coding means arithmetic shift to the right 4 times. By the 4 times, hashtag 4 is 4 times. Next, LSL, we do the coding and it will be logical shift to the left by the 4 times, and then ROR, we save into the R3 and do the rotate to the right. So let's take a look at the result. build, zero error, and then debug. So run the cursor line and step by step. First, we declare R8 as 20FE5690. Next, we shift to the right for the four times. So when we change the R8 number into the binary from hexa to the binary, and we shift the number into the right by four times. And then this is the result. Next, for R2, uh, we logical shift left as usual, change the number into the binary, and shift to the left by the four times. And then ROR, as we can see, it just rotate to the right. So see at the number here, 20FE5690. So number at the back, at the right at the right zero is, we take it and put it at the left, and then 9 will be go to the right and 0 will be go to the left. So that's why we get 020FE569. So next we step again be again, then it will be looping at here at end of the coding. So let's take a look at the question 4. For the question 4, write a program that will perform logical OR for 0x6398 with 0x1DFE. Execute the program and comment on the result. So let's see the coding. I have do the coding. So as usual, do the format of the coding and then again be again and. So first, as usual, we declare the pointer LDR R0 as 0x6398, and next we declare LDR R1 as 0x1DFE. So as the question 1, we use logical OR, so we use ORR. So we store the result into the R2, RO, logical with R1. So let's take a look at the result. Build. So let's take a look at the result. First, we build. So there is zero error. If there is error, so look again at your coding. There is something wrong at your coding. So there is zero error. So we debug, run the program. So we can see at here step by step, run the cursor line and then do the step. First, we declare L0 as 6398, and then next step to the R1, it we declare as 1DFE, and then we use logical OR and save the result into the register 2. R0 logical OR with R1. So let's take a look at the result at the register 2. We get 7FFE. So if you don't know it is true or not, so you can use the calculator. So you pick at the binary base end in your calculator, change to hexadecimal. So press 6398 option choose logical OR, and then 1D FE. So we will get 7FFE. So it is same as the coding. So next we do the step. So we have done the coding, looping at here and then end. We have done the coding, so the result of R2 is right, same as the calculator. Same as the calculator. Okay, next, let's take a look at the question 5. Okay, for question 5, write a program that copy 12 byte of data starting from memory location 0x40040000 to memory location 0x40040020. Set manually. So we must insert the number from 01 and 02 and so on by ourselves in the Khairul. So run the program and comment the result. So let's see at the coding. I have made the coding. So as usual, do the format at here, and between the format there is the coding. So let's run the coding. Build, zero error, and then we start the debug session. Okay, the question say we must at here. The question say set manually the content of memory to be 01, 02, and so on. So at here, you can see it here from 01. Here we set as 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, and C. Okay. So we have set the program manually at here at the memory. So we must so we can look at the step by step how the coding run perfectly. Okay, run the cursor line, and then as usual use tab. R0 will be 3, R1 will be 0x40040000. So why I used R0 is 3. So hashtag 3 is the counter. First I declare the counter. We will see at the question. It say copy 12 byte. So there is 12 counter, but I have made it more complex. That means I don't have repeat the program by 12, but just repeat by use a shortcut. Because memory we can copy 4 by 4, which means 4, 8, and 12. So that's mean 4, 8, and 12. That's mean 3 progress only. So we declare point counter as 3, but at here we must declare as 4, not 1. So we make the program will be 4, 8, and 12. So after we declare R1, we declare value of R2, and then we edit the R3 into R1, and then add by 4 times. But because of the hashtag 4, and then we store the coding into the R3 by 4 times 2. Next, we can see here R2 40040024 by 4 times, and then we will change the result at here 01, 02, 03, and 04 because the coding copy the number from 01, 02, 03, 04 by 4 times, as I said earlier, into the 20, 21, 22, and 23. because we start from 20, so 21, 22, 23. So if we copy into the 21, 22, 20, 20, 21, 22, and 23. Okay, next after store, we must divide the counter by 1 so that we have only 2 progress to make all the coding completely. Okay, after we sub by 1, we compare if R0 is equal to 1. If equal, skip the branch not equal. If not equal, will be branch not equal, and then 9 add LDR R3, store R1, and then hashtag 4 again. So we step by step, we can see step by step. And then R1 will be 4004000008. It will plus by 4 and before 4 and then plus by 4, it will be 8. And then for R2 will be 28, 20, 24, and then 28. So next, after we add the R2, we add the R3 into R2 by 4 times, and then store R2 by 4 times, and we will see it will copy the 05, 06, 07, and 08 into the 24, 25, 26, 27. Okay, next we go through the step. After we finish the second coding, we must divide the counter by 1, and then it will be 1 more progress to do. So R0 is still not equal to 0, so we branch not equal to 9. 9 LDR at here by 4 times. So next, it will be C. So 8 plus 4 will be C. And then R2 will be 2C. 28 plus 4 will be 2C. So let's take a look at here. It will be copy 9, A, B, and C. 9, A, B, and C until 2C. So after we finish the third program, we must divide this counter by 1, and then it will be 0. After 0, that means we have complete all of the program. We copy the 12 byte into the memory location. So after we finish, it will not be branch not equal and then 9 again, but we will skip the line into again, B again, and we have finished the coding. So when we copy from R1 into the R2, it will copy at the starting point until the 12 byte. So let's take a look at the question 6, last question. Okay, for the last question, question 6, write a program to compare data in num into register 2. So num will be equal to R2 if the data is greater than 5. If num is greater than 5, we store the data into memory location 40020000. If the data is lower than 5, we add the data with 0x60 and store it into memory location 40020010. Before that, set the number with value of 3. Num is equal to 3. Use EQU instruction, equal instruction. Run the program and comment on the result. So let's see the coding program. As usual, use format add here and then add here the format. And then the question 1, we use the EQU instruction. So when we use EQU, put it at the bottom before again be again. Okay, let's take a look at the program. As usual, build zero error, and then we run and start the debug session. Okay, let's take a look at the lab 6 one by one. So as usual, use the run to cursor line, then step. We start from here, step. As usual, R0 will be 400200000, and then R1, and then R2 will be num. Num is equal to 3 here. So we compare. If it is R2 if uh, greater or lower than 5. It, if higher than 5, it will jump at here and skip at store and skip the coding at here. So it will jump into lebih, store R2 into R0, B and B again. But R2 is equal to 3 is lower than 5. When the lower, BHI lebih is skip. We not use the higher than. So we add R2 into hashtag 0 at 16 and store it into the R1. So B again, when brush again, we skip at here and go to again at here, and then we looping at here. So let's take a look at the coding. So R2 will be 63 because R2 is lower than 5, and then we store the R1 into the R2. So we see here it is 63. Before this, it is 0, but after we store it to the memory, it will be 63. And then B again, we brush again and then skip the program into again B again, and then we finish the program. So next, I want to say that for the conclusion, maybe for this lab, I have learned many of things from the coding, and I have learned how to use the Kai perfectly with the lab session. So with this question, 6 question is not easy and it's not hard to, but is maybe at between of hard or easy, but it is still okay to do it. And then I use the Kai from newbies and until not a professional, but I can do it as the regular person. So that's all for me. Thank you.